Good day, one and all, and you're all most welcome to this week's CNPS technical session. Thank you very much for tuning in. Today, we actually have the penultimate session of the 8-part series, which we have been witnessing, given by Vladimir Netchitailo on his world universe model. And this has been a marathon session. It seemed that it would be going on for a long, long time. But actually, as far as I'm concerned, it's just gone like that. We've only one more session after today's session. Vladimir has been homing in, from I think, from the very outer reaches of the universe to the Milky Way. He was talking about the Earth the last time, and he's actually concentrating a bit more on Earth matters. So today's part 7 is concerned with high energy atmospheric physics. Okay, and he'll be including actually quite fascinating things like ball lightning, the Tunguska event, 1913 or something, in WUM, the World Universe Model. Terrestrial Gamma-Ray Flashes are in fact gamma-ray bursts. Well, that's his contention. He'll be talking about that. He says their spectra at very high energies are explained by dark matter particles self-annihilation in Geocorona. Now, I haven't changed any of the original description which Vladimir gave me actually at the beginning, before he presented part 1. So I do know that he has sort of renamed dark matter to universal particles or something. He'll talk about that. So you'll forgive me if I've kept that in. Lightning initiation problem is solved by gamma ray bursts that slam into thunderclouds and carve a conductive path through a thunderstorm. The Tunguska event explained by huge atmospheric explosion of Superbolide, which was a stable dark matter bubble before entering the Earth's atmosphere. So with a small change of terminology, I think that will be progressed by Vladimir today. As usual, we have very roughly an hour for the presentation and an hour for questions and answer. But that is not very strict. It's quite possible that the presentation will go on for 15 or more minutes, and we'd welcome that. Or if Vladimir wants to end a bit early, there might be more time for Q&A and also for discussion. Perhaps that's more relevant for the next session, which will be the last session, and he might want to give a little more time for wrap up and questions. But that's completely up to the speaker. And we have 2 means of communication or participation, rather, through the social media, the Facebook and the YouTube, and people frequently use those as a means of commenting between each other and so on and so forth. And I'll be keeping an eye on those. So if there are any specifics, I'll try to intervene. But other than that, I leave the people to discuss matters among themselves. But if they have any specific question for Vladimir, perhaps highlight that so I won't miss it. I'll be able to put it to him. We'll deal with those first, those comments first. And then we'll hopefully have some time to go to the green room, what we call the green room, where we have a number of participants, and they may want a more interactive discussion with Vladimir that we can all witness. So I hope that they'll come up, and if they don't, I might sort of volunteer them myself, because I think it's always valuable to have some back and forth discussion. Okay, so Quest has come in. He says, "I'm here. Is anyone else here?" Well, 1 or 2 people have come in. I think sometimes it takes 5 minutes or so for people to come in. Now, as you know, Vladimir has gone to the considerable trouble, I think, of printing out his presentation. So we actually have not only his presentation, which he's a fairly clear speaker and he speaks reasonably slowly, but he actually will be projecting his presentation, so you can actually read it and you'll be able to go back if you don't understand anything he said. Okay, so So that's it. I don't think there's anything else I have to say today. We're finished with the funding mechanism and so on. Right. So Vladimir is there. I've had a brief discussion with him for a few minutes just before we started to make sure everything was all right. So again, you're most welcome. And I'm in one sense sorry that this is coming so quickly to an end, but it's been a marathon session, and I'm looking forward to today's presentation where you're dealing with very specific elements of Mother Earth that we're experiencing daily. And I trust that what we had hoped is actually materializing now, that things are coming a bit more together. You know, it's been a subject that Vladimir has been working on for maybe half a century, or well, I know he's been in the technical area. He's been working on this for maybe a little less time than that, but we're all not familiar with his thinking. But I think it's becoming clearer as he has sort of pieced the bits together and dealt with some of the questions that some people have asked. And I warrant that as we're ending the next session in 2 weeks' time, things will be a bit clearer as to what his whole world universe model is about, and what its merits are and strengths, and you know, if people think there are defects or things that could be improved also. So so Vladimir, as always, this is something we're very used to. You just project your system up. I assume you're going to do exactly the same as you've done the other 6 times. Just share your screen, project the thing up. I'm going to disappear then, and then I'm going to maximize everything so we won't even have your photograph. Yeah, there it is. You've done it very quickly now. See, we're all dab hands of this. We all know how to do it. So I add to the stage, right? I am going to give the floor in toto to Vladimir, so you won't have to listen to my poor tones, but I will come back with any problems. So Vladimir, welcome again to our presentation on the 22nd of June, 2024, and the floor is entirely yours.
Hello, everyone. Thank you for coming. Let's continue. Earth. In the previous presentation 6, we discussed different aspects of the Earth, a condition of early Earth before the beginning of life on it, internal structure, the 660 kilometers boundary that we named geomagma with electrical conductivity, random variations of Earth's rotational speed on daily basis, origin of moon, expanding Earth, internal heating, faint young sun paradox, Geocorona, and planetary coronas. Our model revealed the fact that the sun and the moon activity causes the geomagma activity, and as a consequence, random variations of Earth's rotational speed by the periodically varying sun's and moon's magnetic field. Today, we will discuss Earth's high-energy atmospheric physics. In his The Mystery of Lightning review, leading lightning physicist Joseph Dwyer provides an excellent overview of the main experimental observations and leading models of thunderstorms and lightnings. Many mysteries remain about how thunderstorms and lightnings work, including how lightnings get started. It is established that thunderstorms and lightnings produce intense bursts of X-rays and gamma rays. These high-energy radiation may be important for understanding how lightning works. In this presentation, we give an explanation for high-energy atmospheric phenomena through the frames of Hypersphere world universe model. In WUM, terrestrial gamma-ray flashes are in fact gamma-ray bursts. The spectra of TGFs at very high energies are explained by universe-created particles self-annihilation in Geocorona. Lightning initiation problem is solved by gamma-ray bursts, which slam into thunderclouds and carve a conductive path through a thunderstorm. High-energy atmospheric physics. Lightning initiation problem. Years of balloon, aircraft, and rocket observations have never found large enough electrical fields inside thunderstorms to make a spark. And yet, lightning strikes the Earth about 4 million times per day. This has led to the cosmic ray model of lightning initiation. Cosmic ray slams into atmosphere and carves a conductive path through a thunderstorm. Air showers alone will not increase the conductivity enough to initiate lightning. A mechanism of runaway electron avalanche was proposed by Gurevich et al. In 1992 in order to increase ionization. Strong electric fields accelerate electrons to nearly the speed of light. These electrons emit X-rays and gamma rays, which were observed by Fishman et al. In 1994. A gamma-ray flash descends from the overhead thundercloud. It is not clear why some discharges make X-rays and others do not. Gamma rays are produced inside of thunderstorms. Explosive production of energetic particles were observed from space by Fishman et al. Thunderstorms create electron and positron beams. Thunderstorms produce terrestrial gamma-ray flashes. Terrestrial gamma-ray flashes were first detected by chance by NASA's Earth-orbiting Compton Gamma-Ray Telescope. Compton was searching for gamma-ray bursts from exploding stars when it unexpectedly began detecting very strong bursts of high-energy X-rays and gamma rays coming from Earth. Detectors observed an unexplained terrestrial phenomenon, brief, lasting about a millisecond, intense flashes of gamma rays. According to Fishman, these flashes must originate in the atmosphere at altitudes above at least 30 kilometers in order to escape atmospheric absorption and reach the orbiting detectors. The photon spectra from the events are very hard, peaking in the high energy portion of the spectrum, and are consistent with Bremsstrahlung emission from energetic mega-electron waltz electrons. The most likely origin of these high-energy electrons, also speculative at that time, is a rare type of high-altitude electrical discharge above thunderstorm regions. An article, Properties of the 100 thundercloud discharges responsible for terrestrial gamma-ray flashes, Dwyer in 2013 provides a brief review of TGFs. They have durations ranging from a few tenths of microseconds to a few milliseconds and produce the highest energy emission of natural phenomena originating from within the Earth's atmosphere. TGFs are relatively common, with thousands or more produced around the planet each day. Spacecraft measurements have found that the source altitudes of the gamma rays must be below 20 kilometers, within the altitude range of thunderstorms. The spectra of TGFs, up to a few tenths of megaelectron volts, are consistent with Bremsstrahlung emissions from energetic electrons accelerated by strong electric fields within the thunderclouds, although there is currently some debate about the spectra at very high energies, about 100 megaelectron volts. It is a challenge to develop models that can explain how large numbers of high-energy electrons are generated so rapidly deep within the atmosphere. According to Dwyer, there are two leading models of TGF formation. Lightning leader emission, similar to X-ray emission seen near the ground. Dark lightning, which generates so many high-energy particles that it discharges the thunderstorm faster than normal lightning. makes currents over 100,000 amps, emits very little visible light that appears dark, can explain terrestrial gamma-ray flashes. Cosmic rays are not needed. But how can we explain a new mystery? A bright TGF was seen by spacecraft in the middle of Sahara Desert on a nice day. The nearest thunderstorm was about 1,000 miles away. Let's summarize obtained results, which are difficult to explain in frames of the existing models. Sometimes ball lightnings appear without apparent connection to a lightning bolt. Unusual surges of radiation at 511 kiloelectron volts when there were no thunderstorms. Beams of antimatter positrons produced above thunderstorms on Earth. A gamma-ray flash coming down from the overhead thundercloud. Some discharges make X-rays and others do not. Explosive production of energetic particles observed from space. Thunderstorms make electron and positron beams. Thunderstorms produce TGFs. A bright TGF was seen by spacecraft in the middle of Sahara Desert on a nice day. The spectra of TGFs at very high energy, 40-100 mega-electron volt. Geocorona is the luminous part of the outmost region of the Earth's atmosphere. It extends to at least 640,000 kilometers from the Earth. X-rays from Earth's geocorona in the range of energies 0.0810 kiloelectron volts were first detected in 1999. The main mechanism explaining the geocorona X-rays is that they are caused by collisions between neutral atoms in the geocorona with carbon, oxygen, and nitrogen ions in the solar wind. This process is called charge exchange, since an electron is exchanged between neutral atoms in geocorona and ions in the solar wind. WUM explanation. The characteristics of geocorona are similar to the characteristics of the solar corona. We discussed it in the presentation 6. The geocorona, made up of universe-created particles, resembles a honeycombed field with plasma, including the ionosphere from about 60 kilometers to 1,000 kilometers altitude. The geocorona, composed of UC fermions, UCF1, UCF2, UCF3, has the size that is much larger than the size of the Earth. At the distance of 640,000 kilometers from the Earth, atoms and molecules are so far apart that the outmost region of the Earth's atmosphere no longer behaves like a gas. As the result of large fluctuation of UC particles in geocorona and their self-annihilation, X-rays and gamma rays are going not only up and out of the Earth, but also down to the Earth's surface. In case they were produced at altitudes of above at least 30 kilometers, they can reach the orbiting detectors. In case the source altitudes of the gamma rays is below about 20 kilometers, within the altitude range of thunderstorms, they can reach the surface of the Earth. TGFs are, in fact, well-known gamma-ray bursts. X-rays and gamma rays are the consequence of UCF1 and UCF2 and UCF3 self-annihilation. The spectra of TGFs at very high energies can be explained by UCF1 and UCF2 self-annihilation. Lightning initiation problem can be solved by X-rays and gamma rays, which slam into the thunderclouds and carve a conductive path through a thunderstorm. From this point of view, it is easy to explain all experimental results summarized above. Ball lightning. Ball lightning is unexplained atmospheric phenomenon that is usually associated with thunderstorms and lasts considerably longer than the split-second flash of a lightning bolt. Ball lightning usually appears during thunderstorms, sometimes within a few seconds of lightning, but sometimes without apparent connection to a lightning bolt. In some cases, ball lightning appears after a thunderstorm or even before it. In 1972, Chairman published a review in which he identified the properties of a typical ball lightning. They frequently appear almost simultaneously with cloud-to-ground lightning discharge. They are generally spherical or pear-shaped with fuzzy edges. Their diameters range from 1 centimeter to several meters, most commonly 10-20 centimeters. They can be seen clearly in daylight. The lifetime of each event is from 1 second to over a minute, with the brightness remaining fairly constant during that time. They tend to move most often in horizontal direction at a few meters per second, but may also move vertically, remain stationary, or wander erratically. Many of them are described as having rotational motion. It is rare the observers report the sensation of heat, although in some cases the disappearance of the ball is accompanied by the liberation of heat. Some display an affinity for metal objects and may move along conductors such as wires. Some appear within buildings, passing through closed doors and windows. Some have appeared within metal aircraft and have entered the left and left without causing damage. The disappearance of ball is generally rapid and may be either silent or explosive. So many variations. Short history of ball lightning hypothesis. Different hypotheses were proposed to explain ball lightnings, but no one explanation is widely accepted at present. Vacuum hypothesis by Nikola Tesla, 1904. Microwave cavity hypothesis by Peter Kapitsa. Antimatter hypothesis by David Ashby and Colin Whitehead. Maser solid tone hypothesis by Peter Handel. Black hole hypothesis by Mario Rabinovich. Microwave bubble hypothesis by WUM. Extreme ball lightning hypothesis. Van Devender in 2011 distinguished extreme ball lightning from ordinary ball lightning by the following characteristics. It glows in air. It originates from nothing visible. It lasts between 10 and 1200 seconds. It is lethal or potentially lethal. It causes significant damage. It contains energy estimated at 100,000 to 1 billion joules, far in excess of the energy density attributable to chemicals or electrostatics. It penetrates walls, glass, and metal, generally without leaving a hole. It leaves black streaks on corpse without the spasm of electrocution. It can excavate tons of earth. Extreme ball lightning in County Donegal, Ireland on August 6, 1868 traveled about 1.6 kilometers and excavated about 200 cubic meters of water-saturated pit in about 1200 seconds. Van Deventer followed up a reputable report by Michael Fitzgerald to the Royal Society with a visit to the site. He confirmed the essentials as far as it was possible so long after the event. It was evident that the conductive pit would immediately neutralize any charge, so extreme ball lightning cannot be electrostatic. According to Van Devender, to date, no theory addresses the characteristics of extreme ball lightning. He said it seems to require new physics. In view of Thornhill in 2006, explaining extreme ball lightning does not require new physics. The clue of his hypothesis comes from the observed ability of extreme ball lightning to penetrate solid material. According to Thornhill, there is one stable particle that has the ability to pass through solids without any appreciable effect, neutrino, which in the presence of the excited nucleus may accept a lower level of energy than required for pair production and form a stable heavy neutrino. There is only one defect of this hypothesis. Neutrinos have no energy at all. Observations of characteristics of ball lightning. One particular large example was reported on the authority of Dr. Gregory in 1749. Admiral Chambers, on board of Montague for November 1749, was taking an observation just before noon. He observed a large ball of blue fire about 3 miles distant from them. They immediately lowered their topsails, but it came up so fast upon them that before they could raise the main tack, they observed the ball rise almost perpendicularly and not above 40 or 50 yards from the main chains when it went off with an explosion as great as if 100 cannons had been discharged at the same time, leaving behind it a strong sulphurous smell. By this explosion, the main topmast was shattered into pieces, and the main mast went down to the keel. 5 men were knocked down, and one of them were bruised. Just before the explosion, the ball seemed to be the size of a large millstone. Observations of the optical and spectral characteristics of ball lightning was made by Sen et al. In 2014. At a distance of 900 meters, a total of 1.64 seconds of digital video of the ball lightning and its spectrum was obtained from the formation of the ball lightning after the ordinary lightning struck the ground up to the optical decay of the phenomenon. The ball lightning traveled horizontally across the video frame at an average speed of 8.6 meters per second. It had a diameter of 5 meters. Oscillations in the light intensity and in the oxygen and nitrogen emission at a frequency of 100 Hz, possibly caused by the electromagnetic field of the 50 Hz high voltage power transmission line in the vicinity, were observed. From the spectrum, the temperature of the ball lightning was assessed as being lower than the temperature of the parent lightning, less than 15-30,000 Kelvin. The observed data are consistent with vaporization of soil as well as with ball lightning sensitivity to electric fields. Nikitin et al. In 2023, in the article Explosions of Ball Lightnings Inside Enclosed Spaces, estimated the value of energy density of highly energetic ball lightning, it's about 10 to the power 10 joule per cubic meter, and the energy of the explosion of this ball lightning to be equal to 130 megajoules. These estimations allowed the authors to say that ball lightning is a dangerous natural phenomenon. On figure 1, we can see the result, the house wall thrown out by this explosion. You see there is only wall and there is no any other residual stones and some other particles. There is only explosion. According to Oreshka in 2012, Kapitsa supposed that a ball lightning is a window in another world. We analyzed the possibility of existence of other worlds, micro world, small world, and large world, based on the proposed weak, super weak, and extremely weak interaction, respectively. It was suggested that ball lightning is an object of the small world. Macro world. In WUM, strength of gravity is characterized by gravitational parameter g, where g0 has this expression, is an extrapolated value of g at the beginning of the world. T is the gravitodynamic constant, H is the Planck constant, and A is a basic size unit about 10 to the minus 14 meters. Dimensionless time-varying quantity Q is a measure of the age of the world that equals tau over T0, where tau is the cosmological time and basic time unit T0 equals to about 10 to the minus 23 seconds. In the present epoch, Q equals about 10 to the power 14. The range of gravity equals to the size of the world, about 10 to the power 26 meters. WUM foresees the three additional types of interactions between universe-created particles, weak, super weak, and extremely weak, characterized by the following parameters respectively. In our view, each type of UC particles interactions provides integrity of the corresponding world. Microworld is characterized by the parameter G weak, which is about 30 orders of magnitude greater than G. The range of the weak interaction for USC particles with Compton length LUCP in the present epoch equals to this equation. For example, particles UC fermion, UCF1, with the rest energy 1.3 tera-electron volts, where alpha is a dimensionless Rydberg constant and the basic energy unit E0 equals to 70 mega-electron volts, have Compton lengths about 10 to the minus 18 meters. And the range of the weak interaction about 10 to the minus 8 meters. That is much greater than the range of the weak nuclear force. It's about 10 to the minus 16, minus 70 meters. Small world is characterized by the parameter G super weak, which is about 20 orders of magnitude greater than G. The range of the super weak interaction for the particle UCF1 equals to 82.2 meters. In WUM, ball lightnings are macro objects which have cores made up of weakly interacting particles UCF1 surrounded by shells composed of the electron-positron plasma contaminated by chemical elements of soil and air as the result of TGF strike of the ground. Super weak interaction between particles UCF1 and all particles around the core provides integrity of ball lightnings. Large world is characterized by a parameter G extremely weak, which is about 10 orders of magnitude greater than G. The range of the extremely weak interaction in the present epoch equal to this equation, that it equals to 1.5 light years or about 96,000 astronomical units. In our view, extrasolar systems are large world objects. Extremely weak interaction between universe-created matter cores and all particles around them provides extrasolar systems integrity. Ball lightning formation. The clue of our model comes from the observed ability of ball lightnings to penetrate solid materials. It means that the core of ball lightning should be composed of UC particles. Following Tesla vacuum hypothesis, we suppose that when sudden and very powerful TGF passes through the air and strikes the surface of the Earth, the tremendous expansion of some portions of the air and subsequent rapid cooling and condensation gives rise to the creation of partial vacua in the places of greatest development of heat. These vacuous spaces, owing to the properties of the gas, are most likely to assume the shape of hollow spheres when, upon cooling, the air from all around rushes in to fill the cavity created by the explosive dilatation and subsequent contraction. In WUM, the places of greatest development of heat are the spots on the Earth's surface struck by TGF. As a result, the ablation of the soil takes place, and vaporized chemical elements of soil and the oxygen and nitrogen from the air can be absorbed by ball lightnings and observed experimentally. Very powerful gamma quants with energy at least 1 megaelectron volts in the vicinity of atomic nuclei of the ground can produce electron-positron pairs with high concentration. These collisionless, unmagnetized electron-positron plasma, whose properties are very well studied, composes a shell around UC meta core of ball lightning made up of UC fermion 1 and provides the affinity for metal objects such as wires. The most important part of the ball lightning formation is UC meta core. The calculated density of Geocorona composed of particles UCF1 near the surface of the Earth is about 10 to the minus 7 kilogram per cubic meters. Let us calculate a radius of sphere in Geocorona having mass about Planck mass. It's about 0.275 meters. That is a reasonable size of Geocorona bubble. UCM core of the ball lightning has a maximum energy in accordance with plus Planck mass about 10 to the power 9 joules. That corresponds to the estimated by van de Wander value 10 to the power 5, 10 to the power 9 joules, and by Nikitin et al. 130 megajoules. In accordance with vacuum hypothesis by Nikola Tesla, when powerful TGF strikes the surface of the Earth, the explosive dilatation of the portion of Geocorona with radius RGC gives rise to the creation of hollow sphere with partial vacuum and all UC particles outside of the sphere. The subsequent rapid contraction induces UC particles rush in to fill the cavity. As a result, at the center of the sphere arises micro-objects with mass about Planck mass and density high enough for the beginning of the UC particles self-annihilation. According to WUM, all gravitationally rounded macro objects in hydrostatic equilibrium down to the moon of the Saturn Mimas have UCM reactors inside of them. Considering that the mean density of the Mimas is about 115,000 kilogram per cubic meter, with UCM core made up of self-annihilating UCF1, we can estimate an average density of the core about 1,000 kilogram per cubic meters as the minimum density for the effective self-annihilation. Then the size of the core is about 10 to the minus 4 meters. Mass of the small ball lightnings is mostly in the UCM cores. Then they can easily penetrate through walls, glasses, metals without leaving a hole. Considering the density of the atmosphere about 1.25 kilogram per cubic meter, we can calculate the minimum radius of the ball lightning corresponding to the core's mass only 0.16 centimeters. That is in a good agreement with experimentally observed value of ball lightning minimum size about 1 centimeter. We take density of the atmosphere for the average ball lightning density to explain movement of ball lightning in air. Practically all mass of extreme ball lightnings is in electron-positron plasma. Extreme ball lightning with diameter 5 meters observed by Sen et al. In 2014 had a mass of about 82 kilograms. As a conclusion, ball lightning belongs to the small world. Ball lightning has the core made up of UCF1 surrounded by the electron-positron plasma contaminated by chemical elements of soil and air as the result of TGF strike of the ground. The core of ball lightning irradiates quants with different energies and attracts new UC particles from Geocorona due to super weak interaction. It explains the observed result that the brightness of ball lightning remains fairly constant during its lifetime. UC particles supply not only additional mass, but also additional angular momentum. It explains the fact that many of ball lightnings are described as having rotational motion. Tunguska event observations. On June 13, 1908, at around 7:17 a.m. local time, Evenki natives and Russian settlers in the hills northwest of Lake Baikal observed a bluish light nearly as bright as the sun, moving across the sky and leaving a thin trail. About 10 minutes later, there was a sound similar to artillery fire. The explosion registered at seismic stations across Eurasia, and airways from the blast were detected in Germany, Denmark, Croatia, and the United Kingdom, and as far away as Batavia, Dutch East Indies, and Washington, D.C. It is estimated that in some places the resulting shock wave was equivalent to an earthquake measuring 5.0 on the Richter magnitude scale. Description. Tunguska event was an explosion, estimated to have a yield of at least 330 megaton of trinitrotoluol. The explosion is generally attributed to a meteor burst, atmospheric explosion of stony asteroid about 50-60 meters in size. The asteroid approached probably with a relatively high speed of about 27 kilometers per second. Though it is classified as an impact event, the object is thought to have exploded at an altitude of 5 to 10 kilometers rather than having hit the Earth's surface, leaving no impact crater. There have been about 1,000 scholarly papers, most in Russian, published about the Tunguska explosion. It's very important that there was no impact crater. Meteor airburst is a type of airburst in which a meteoroid explodes after entering a planetary body's atmosphere. This fate leads them to be called fireballs or bolides, with the brightest airbursts known as superbolides. Such meteorites were originally asteroids and comets of a few to several tens of meters in diameter. A bolide is a fireball reaching an apparent magnitude of -14 or bright, more than twice as bright as the full moon, A superbolide is a bolide that reaches an apparent magnitude of -70 or brighter, which is roughly 100 times brighter than the full moon. Recent examples of superbolides include the Satas Mill meteorite in California, an energy yield of about 4 kilotons of TNT, the Chelyabinsk meteor in Russia, the explosive energy 460-470 kiloton of TNT, and the Kamchatka meteor in Russia, which was an asteroid roughly 10 meters in diameter, entered the atmosphere at a speed of 32 kilometers per second, with a TNT equivalent energy of 173 kiloton. This energy was more than 10 times the energy of the little boy bomb dropped on Hiroshima in 1945. Early estimates of the energy of Tunguska airburst ranged from 10-15 megaton to 30 megaton of TNT, depending on the exact height of the burst as estimated when scaling laws from the effects of nuclear weapons are employed. The 15 megaton estimate represents an energy about 1,000 times greater than that of little bomb. It equals to that of the United States Castle Bravo nuclear test in 1954 and one-third that of the Soviet Union's Tsar Bomba test in 1961. UC government census reported 971 entries of fireballs from May 1988 to December 2023. It's a pretty usual phenomenon. Earth impact model. Meteorites enter the Earth's atmosphere from outer space, traveling at speeds of at least 11 kilometers per second, and often much faster. Despite moving through the rarefied upper reaches of the Earth's atmosphere, the immense speed at which a meteor travels rapidly compresses the air in its path. The meteoroid then experiences what is known as ram pressure. As the air in front of the meteoroid is compressed, its temperature quickly rises. This is not due to friction, rather it is an adiabatic process, a consequence of many molecules and atoms being forced to occupy a smaller space. Ram pressure and the very high temperatures it causes are the reasons few meteors make it all the way to the ground. Most simply burn up or are ablated into tiny fragments. Larger or more solid meteorites may explode instead. As theorized by Cooper in 1951, a disk-like belt of icy bodies exists beyond Neptune. These icy objects, occasionally pushed by gravity into orbits, bringing them closer to the Sun, become the so-called short-period comets with less than 200 years to orbit the Sun. A comet is an icy, small solar system body with nuclei composed of loose collections of ice, dust, and small rocky particles. There are two main classes of comets: short-period comets, called ecliptic comets, and long-period comets, called isotropic comets. Ecliptic comets have relatively small orbits below 10 astronomical units and follow the ecliptic plane, the same plane in which the planets lie. All long-period comets have very large orbits, thousands of astronomical units, and appear from every direction in the sky. How and when comets formed is debated, with distinct implications for solar system formation, dynamics, and geology. An asteroid is a minor planet an object that is neither a true planet nor a comet that orbits within the inner solar system between the orbits of Mars and Jupiter. They are rocky, metallic, or icy bodies. Sizes and shapes of asteroids vary significantly, ranging from 1 meter rocks to a dwarf planet almost 1,000 kilometers in diameter. The total mass of the asteroid belt is about 3% that of the Moon. WUM explanation. Main results of meteor air bursts are: they are a type of air burst in which a meteoroid explodes after entering a planetary body's atmosphere. This fate leads them to be called fireballs or bolides, with the brightest air bursts known as superbolides. Comets are leftovers from the dawn of solar system around 4.6 billion years ago and consist mostly of ice coated with dark organic material. They have been referred to as dirty snowballs. How and when comets formed is debated, with distinct implication for solar system formation. Asteroids and comets formation. In frames of WUM, ecliptic comets were produced by the Sun itself as the result of volcanic rotational fission of the Sun's UC matter core 4.57 billion years ago. Nearly isotropic comets were produced by giant planets with different directions of their rotational axis, which are in fact failed stars as the result of the rotational fission of their UC matter cores. In our view, random explosive volcanic rotational fission of the Sun's UC matter core looks like a firework of UC matter cores of satellite objects at the same time, so that the direction of the Sun or the satellite's angular momentum coincides with an angular momentum of the Sun. There are no preferences of directions of satellites versus random rotation direction. UC cores of satellite objects can be any size from 1 meter to thousands of kilometers. Satellites are rocky, metallic, or icy bodies as the result of the self-annihilation of UC particles inside of their cores, in case when a density of cores more than 1,000 kilogram per cubic meter. That is enough for the efficient self-annihilation. All compositions of asteroids and comets are homemade. Formation of all objects in solar system has a good explanation. Tunguska Superbolide. In case when the density of UCM cores of satellite is less than 1,000 kilogram per cubic meter, the self-annihilation process is not efficient. Then there is a possibility of stable UCM metabolites, which are the analog of extreme ball lightnings with much larger internal energy. The range of weak interaction for particles UCF1 is about 10 to the minus 8 meters. We calculated it before. And a calculated minimum particles concentration, about 10 to the power 24 per cubic meter. Considering the rest energy of UCF1, 1.3 tera electron volt, we can calculate the minimum energy density of UCM core, about 10 to the power 17 joule per cubic meter. That is equivalent to the mass density of 3.44 kilogram per cubic meter. That is not enough for the efficient self-annihilation. Tunguska Superbolide has the calculated maximum energy about 10 to the power 17 joules. It means that a maximum of its UCM core volume is about only 0.4 cubic meters. The calculated maximum diameter of the superbolide is 482.2 meters. We calculated it before. In our view, weak interaction of particles UCF1 provides the integrity of the superbolide's core and super weak interaction of the superbolide itself. Tunguska superbolide is a stable macro object before entering the Earth's atmosphere. Superbolide entered the Earth's atmosphere from outer space, traveling at speed of 27 kilometers per second. Despite moving through the rarefied Earth's atmosphere, the immense speed at which it traveled rapidly compressed the air in its path. The superbolide then experienced ram pressure. As the air in front of it is compressed, its temperature quickly rises. Ram pressure and the very high temperatures caused increasing of the UCM core's energy density up to the critical value of 1000 kilogram per cubic meter, when the efficient self-annihilation of particles UCF1 took place and UCM matter core exploded. Conclusion. It is important to emphasize that the initial energy required for a extreme ball creation is insufficient for its sustenance of up to 1200 seconds. Additional energy, therefore, must be consumed by extreme ball lightning once it had been formed. WUM predicts a new phenomenon, a generation of ball lightnings according to the proposed model of them. Once we master the creation of ball lightnings and extreme ball lightnings in a controlled environment, we can concentrate our efforts on harvesting that energy from a practically infinite source, the medium of the world with UC particles. World-universe model can serve as a basis for high-energy atmospheric physics. Acknowledgements. As usual, I am always grateful to academician Prokhorov and Professor Manenko, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Corden for publishing my manuscript in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival and Harry Ricker for valuable comments and suggestions which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify, model, and improve its understanding. This is the end of the presentation. Thank you so much for your attention. I'm ready for your questions. See you there.
Well, thank you very much once again, Vladimir. Your very clear exposition is also very timely. I don't know how you calculate so accurately to the hour, to the minute, to the second almost, but thank you very, very much. And there are a lot of responses have been coming in. So I think, let me see, can I get the presentation down for the moment? Yes. Quite fascinating, a number of the expositions which you are claiming for WUM applied to some of these phenomena on Earth that are not totally understood. The Tunguska, actually it's 1908. I think I incorrectly said 1913 earlier, but that phenomenon and perhaps the explosion of the meteorite, seems to be explained by you. Just maybe a general question about the ball lightning business, because that's all quite fascinating as well. I mean, it appears to me that there could be some ramifications in meteorology, because it's a hitherto misunderstood or not understood phenomenon. And I'm wondering, have you made any overtures to the meteorological authorities with regard to some of your ideas with regard to quantifying and explaining the ball lightning phenomenon?
I sent my published papers and about these issues too for Earth for more than 10,000 people, scientists. And unfortunately, not much responses I have from them. I don't know why, because usually people, they are very conservative. They follow some models, some theories, and to accept a principle, a new model, it's very difficult for them. That is why all my presentations I'm writing and reading. Why? Because so much information, so many details, everything so new that I follow the recommendation of Nick to read the writing. It will easier for people to understand what I'm talking about. That's why, unfortunately, not so much response I have from the expert in this business.
And of course, that will be an experience that is somewhat familiar and germane to many of us in the dissident community. So we're not terribly surprised, maybe, by that.
Yes, but let me tell you that as one of the comments, over 500 people, they saw my paper with high atmospheric phenomena on the Earth, but not so much response, as I was expecting.
Okay, well, maybe we could spend just some moments going through the questions. Again, there have been a lot of conversations back and forth, and I've maybe just tried to contribute once or twice. Is anything that we need to address? We need to put to Vladimir now to get his comment. Just a question that he said that the lightning is not. He said generally lightning is not totally understood. Questions that, some of these things are right. A lot of these are not very specifically to do with today's lecture. Now, that's fine if you want to use this as a medium platform to discuss some of these items. That's fine, but I don't think we need to bring them up today. Let me see. Yeah. I think one of the questions later on was very, very general. And I said, well, maybe that's something one might bring up at the end of the last session. But then he came back and said, no, why do we have to do that? I said, we don't have to do that. It was only a suggestion. We can bring it up today if you wish. And I'll do that in a moment when we come to it. Here it is. It was quite a general conclusions. So let me see what Quest has said.
Maybe meantime, let me make my, I would like to stress that all these phenomena, ball lightnings, extreme ball lightning, Tunguska event, they have the same origin, the same structure. There is the difference only in sizes. That's it. And energy inside of the, you see a matter core of them. That's it. Simple like this. All of them the same. Ball lightnings we can see, extreme ball lightnings we can see on Earth. And Tunguska event, it's a huge, extreme, not extreme, but huge ball lightning in space. Came to us as an ecliptic meteorite. It's not meteor, it's not stones, it's not something else. It is stable ball filled with, you see, a matter core and particles around.
And you are just deprecating the proffered explanation that it is electrostatic. You disagree with that?
Oh yeah, no doubt, because it contradicts to experiments and chemistry. They cannot provide this energy density and so much energy. Like 1,000 of a little boy, explosion in Hiroshima. Can you believe it? It's 1,000 higher. There is no way to explain it by any other possibility, physical laws. That's why more than 100 years, there was no explanation for ball lightnings, extreme ball lightnings, and the Tunguska event, because it was the original idea was not right. Electrostatic, chemicals, they don't work. It's too small, too little energy there.
Okay. So, well, this was the thing. Quest says, what are the ultimate conclusions that you find for all this extensive data? And I said, well, that might be something we certainly can come back to in the next presentation. But he correctly says, why do we have to? Well, I didn't say we had to. I said it was just a suggestion. So I've promised that we can deal with it now. I mean, that's a very, very general question, Vladimir. So, well, perhaps what we'll do, with your permission, and maybe if Quest can agree to this, in your summary of today's presentation at the end, in another 3/4 of an hour, you can just maybe indicate some ultimate conclusions or general conclusions, because it's a very hard question to answer specifically at this stage. Okay. Some type of atomic. Okay. Well, I think we might be giving more time to the green room today, because a lot of these things are discussions between the participants, which, as I often say, are to be welcomed. I'm just pointing out what they are, not criticizing them. Yeah. Okay. Okay. Yeah. Well, I don't know. Robert K is sort of characterizing maybe some of your ideas in this way: contamination, self-annihilation, explosions, plasmas, volcanoes, self-creation, hypersphere world. Do you think that's fair enough, or is it fair summary, or is it too simplistic?
You mean, I'm ready to answer all the questions. Let's not wait until the last one. That's why, if there is some interesting question, it will be interesting for me to hear it and to try to answer. Because, the last time about Earth, not so many questions. Now about so huge phenomena in our motherland. Don't forget that 971 fires were already fixed by special station or in United States. That's why it is not so seldom. No, it's a usual phenomenon, but only the size of this phenomenon might be huge depending on the energy accumulated inside of these macro objects.
Shockwave has introduced the idea of a plasmoid, as a coherent structure of plasma and magnetic fields. He's not, I think, himself saying this or denying it, but he says they have been proposed to explain natural phenomena such as ball lightning. Any response to that, Vladimir?
I showed you already so many different models of ball lightning. It may be one of the existing models, hypotheses, and so on and so on. I don't mind. People, for 100 years, they proposed so many different. I named only a few of them. It's hundreds of different hypotheses, but my understanding that they don't work because there is no way to collect the energy equivalent to 1,000 bombs in Hiroshima. I don't know how to do it with all other
This is like
type of
the power of an H bomb, really, rather than an A bomb.
Yes, yes. What is important, even the most powerful bomb of United States equivalent, but a little bit more Tsar bomb in Russia. That's it. You can compare with the best, attempts of the people to produce some thermonuclear explosions with the same energy. That's very difficult. That's why all the other mechanisms, they don't work. There is no way.
Okay. Well, we'll keep an eye. We'll keep an eye on the discussion and the questions. Okay. Actually, Dennis Allen has his hand raised, so I'll perhaps invite Denny to come on. Good day to you, Denny. You're very welcome.
Hello, Danny.
So, what's your point? You're muted, I think. We can't hear you, Denny. I think you'll have to unmute. Yes.
Can you hear me
unmute
now?
yourself. Yes.
Okay. I just wanted to make a brief comment. And Neil Granow and his Professor Peter Granow from MIT and Neil Granow, his son, in their book Newtonian Electrodynamics, have offered a explanation of lightning and thunder, and the fact that Vladimir mentioned that there's a shortage of energy in most of the explanations. As I mentioned in a previous session, if you accept the idea of Newtonian electrodynamics, which I put forth, that inertial mass is variable, and consequently free kinetic energy is possible. So that's the explanation I gave for the Granow's two famous experiments. One, the exploding wire phenomena, and the other is the Ampere hairpin type experiment, both of which were explained by the fact that electrons can gain a large percentage of their inertial mass when rapidly accelerated non-linearly. And so there's free energy available here, which explains why there is sufficient energy in this sort of explanation. Actually, the Granows I don't think, no, well, maybe Neil, I sent him some emails, but the Granows, Peter is dead, he died, but the Granows didn't understand why Newtonian electrodynamics, which had predicted the exploding wire phenomenon and the Ampere hairpin type thing, they couldn't explain it in terms of classical physics. But if you accept the fact that the electrons, when greatly accelerated non-linearly, gain huge percentage-wise, huge amounts of inertial mass, then you don't have this problem of where's all the energy coming from. It's free energy from the fact that inertial mass is variable. And but based on Ampere's original law and Ampere's original work, they have offered Granows have offered an explanation for lightning and thunder, and my new Newtonian mechanics explains where all that energy can come from.
Okay, as for energy, I told you can collect some energy in any process, but to collect 1,000 bombs like, in Hiroshima, it's impossible by this way. The second very important point, we are not talking about these balls only. We are talking about high energy atmospheric effects like gamma quants, X-rays, and all this stuff. In your model or in this hypothesis of Peter Granau, do we have any explanation of gamma quants up to 100 mega electron volts and all this stuff? There is no only one phenomenon. In my model, I am trying to explain at the same time different features of this phenomenon. It's not only, ball. No, it is X-rays and gamma rays. It is electron, positron, plasma, all these beams in our air, 971 fireballs and all this stuff in upper air. It's over 30 kilometers altitude of this, phenomenon. That's why you cannot apply any theory on Earth to the atmospheric effects at so high altitude. I don't know. I cannot even imagine what kind of physics we can put on this height over Earth to produce all these beams, radiations, X-rays, gamma rays, and all this stuff. That's why, please take my model as the whole model, the whole picture of the whole world around. It's not one particular phenomenon. It's all of them at once. That's why your proposals is good. I don't know what does it mean, rest energy variable. I don't know what is a nonlinear acceleration, but it's in any case, it's a small energies. There is nothing to talk about. Self-annihilation, it's a remove. You have two particles with tera-electron volts. When they will self-annihilate, you will have energies, tera-electron volts at once. One step and you have this energy. That's why, there is only one way to have maximum energy density if you have some kind of annihilation of some particles. Electron, positron, we know. And I have right now, you see particles that they can self-annihilate. That's it, simple like this. You cannot produce this energy density and these energies without annihilation of any particles.
But is it true to say that the Granos have attempted to explain these phenomena in terms of more conventional ideas, whereas yours are very radical? So I'm interested to hear what the Granos might think.
There is nothing in literature close to my idea, to my model. Yes, sir. Without universe created particles with these characteristics self-annihilating, it's impossible to explain. It's impossible. That's it. And all the other gamma rays, X-rays, all this, And what is important? We have X-rays at 640,000 kilometers from Earth. How come? What we're gonna do about it? How to explain it? But it is well known that corona, solar corona, is more than 10 times larger than the size of the sun. The same story with Earth. We have our Geocorona far away from the surface of our Earth. That's why you can observe these effects far away, where there is no gas, there is no molecules at all. They're kilometers apart. That's why, please try to collect all the phenomena, all the facts I told even in this presentation, and to see that my explanation follow all of them, explain all of them at once.
I know that Neil Grano has been in touch. I think probably with you, Denny, but I think he was endeavoring to participate in some of our conferences. We haven't sort of seen him recently, but maybe in time he'll have a look at this and give us some feedback on Vladimir's thesis.
As far as the Tunguska event, that was an explosion in Siberia, right?
Yes.
Yeah. About that time, Nikola Tesla had built his magnifying transmitter, I believe he called it, and he had been tricked by a financier who then tore down his machine shortly after this Tunguska event. And it's a lot of people think that he tried it. Tesla tried out his machine on Siberia, since it wasn't populated. There was no people up there in that part of Siberia, and his magnifying transmitter was what blew up that area. Here again, Tesla was on much closer to the Grandhouse than to Einstein in his special theory of relativity.
You know, I know some ideas about Nikola Tesla. I read most of his papers. You know, I love him. He's a genius guy. He was a genius guy. And if he could do something from Tunguska event, what about Chelyabinsk? What about Kamchatka? What about 971 fireballs we have observed now? He's dead long time ago. That's why, you know, there are some speculations about his influence on this Tunguska event. And he was a very unique guy, by the way. His behavior was not as a usual guys. He always had something behind him. He behaved like a unique guy from outside of the earth, and so on and so on. He was a unique guy. That's why I don't believe too much about he could produce this Tunguska event. No doubts about it. I read about it, believe me. But I love him. I love him. He was genius, not because of Tunguska event, because of the main ideas I used in my model.
Well, you know,
Yeah, certainly so. But
go ahead.
well, I was just going to say that, you know, it's interesting, but perhaps because of his great genius and great ability, certain things have been attributed to him, you know, whether there's evidence or not. And maybe, I don't know if he claimed anything like that himself, a bit like, unlike, say, Werner von Braun, who is meant to have said that he had help from outside, from some other aliens or spiritual or something in the space program. Maybe Tesla didn't say things like that. But what do you say, Danny?
No.
Eric P. Dollard, who is known as the new Tesla, has also, I'm told, built a magnifying transmitter, and it worked too. So it's been, and they say nowadays the Russians under Putin are also working on that in that area as far as weapons are concerned.
Yeah, and I think earlier on it was the death ray, you know, which I think
yes.
to many.
I read everything about it. His behavior, he was like he was an alien already. You know, that's why we cannot evaluate him by our standard senses, standard feelings, and so on and so on. His behavior, his creativity, what we have right now with electricity, it's everything him. And so many proposals, so many genius ideas. That's why, you know, I was very impressed when I read all of his papers. Dennis, please give me my email or some reference to Gronau, and maybe we'll talk with him, with Peter, no, but maybe with his Neil, you know, and I will be more than happy to have a professional talk with them.
Well, Neil is working with, last I heard, working with the British on nuclear weapons now, and I doubt if he can say too much anymore. He's, you know, once you get into weapons research like that, they give you a security clearance and tell you that there's certain things you can't say or you'll be jailed.
But if he published the book, and at least inside of the book, he put something not so sensitive. That's why, you know, let's talk with him about his ideas published without the security. Okay,
well,
please.
Once you're into weapons research, I had to get a security clearance myself when I went from Berkeley to my UC Berkeley to Bell Telephone Laboratories at Homedale, New Jersey, I had to get a security clearance, and there was a lot of things I couldn't talk about.
Okay.
But if, just to finish, I mean, if you're ever in contact with Neil Denny, you might say, is he aware of Vladimir's work? You might ask him.
Yes, that's it. Please give him information about, and it is his choice. You know, he wants to contact me. It's okay. If not, it's okay too.
Well, I don't think he can anymore. Now that he's into nuclear weapons research, he had better watch his step as to what he says and who he contacts.
Oh, well, okay. Well, maybe that's why he hasn't been participating in any of our work over the last number of years, which is probably unfortunate. Okay, Danny. Anything else before we move on?
No, that's it. Thank you.
Well, thank you for that contribution.
Thank you so much for coming and asking this good question.
Very much.
In reference to his book.
Okay. Now, right, and that's interesting as well. Okay. Anybody else in the green room would like to volunteer or to ask a question before I sort of ask for contributions? Because I see we have Nick who came in early, then Jim came in. I'm sorry, I did delay a little to put up the link, and I know Jim needs that. But I see Harry has joined us as well. So I'd like to give you an opportunity. Nick, could you just maybe update us a bit on having heard this further work, which obviously you're somewhat familiar with because you did help Vladimir, but nevertheless, yes, applying to the upper atmosphere phenomena, it seems quite revolutionary what Vladimir has been doing. No, you're mute. You're mute. You'll have to unmute it. Right?
Yes, I found it quite interesting that we had these 6 talks on cosmology, and then it seemed like going off into a totally different area, but it really is just an extension of those 6 areas. So I think that was quite excellent, quite stimulating. I don't know how you got to the time to read all about all of these things. There was one part that I wish you would expand on due to my ignorance. On page 7, you were talking about the micro, small, and large. I don't know what you call them, worlds. Is that different domains for physics? You have different sets of predominant phenomena on those, or what? I'm just not familiar, so maybe I'll go and reread those pages, but I'm looking for a kind of a high-level conceptual explanation of those terms.
Conventionally, they only talk about 2, maybe, the macro and the micro. I suppose you're talking about the further one, Vladimir.
Yes, yeah, you're absolutely right. It's a new concept. You know, let me start up point. It was weak interaction, WIMPs. Do you know WIMPs? Everybody talking about WIMPs, and nobody never told what does it mean, weak interaction of them. No doubts about it. You know, that's why weak interaction, it's well-known, in fact, everybody talking, but nobody gave the definition of it. What does it mean? What is the difference between weak interaction of particles with nuclear weak interaction? You know, the range is so different. That's it. The second very important point. Long time ago, I checked some, even in quantum physics, some published papers about super weak interaction. And a couple of them, I found that even in standard quantum physics, there are some features about super weak interaction. But one more time, there is about 10 orders of magnitude less, but no any definition. As for the extremely weak, nobody even told about, never. But I introduced them because to explain the stability of different macro objects in the world. As I told you today, small world and the micro world. It's an area of my ball lightning and so on and so on. But when you are going to solar systems, supposedly, and you want to have a stable macro object, big one, solar system overall, you must find the way how to hold these particles inside of these bubbles. And this is an extremely weak interaction. It works and it holds our solar system in one piece. The same story with Fermi bubbles. You know that Fermi bubbles, we cannot see them in a visible spectrum. We can see only X-rays, gamma rays, and so on and so on. That's why, it was a wrong definition of myself, dark matter, dark matter. It's not dark. You can see these Fermi bubbles by gamma telescope, no doubts about it. But what is the most important? How to hold these bubbles together. Why they have a stable boundary around. Why there is no spreading. It's a consistent border, and there are some inside gamma radiations and nothing outside. That's why, to explain all these cosmic balls, galaxies, extrasolar systems and planets and all this stuff, you must have some interaction between particles to pull them together, to provide integrity of this macro object. That is why I introduced all these different concepts, different definitions, but I gave a real number. I put it only through parameter Q, and Q is the parameter. It's a so-named Dirac large number. And then I took different, powers of this value. That's it. Simple like this. Remember, I started to build my model based on two parameters only. And I didn't have any choice. I have only alpha and Q. That's why when I started to think about what is the range of this interaction, I have only one parameter, Q, in different powers. It's exactly was my idea, and I realized this idea in this presentation too.
Yeah.
It's a principally new approach.
One final point, you mentioned it, but we have things like ball lightning and whatnot that have tremendous energy density. And you mentioned, what if we could focus on capturing this source of free energy? That's an extremely important point.
Okay. Thank you so much for evaluation.
Just emphasizing that we should do them.
Yes.
But, yeah.
You know what? I hope that some days maybe people, they will put their attention to this way to produce these balls, lightnings, and to use the free energy from the surrounding medium.
Right.
It's my dream. I don't know. Can I live so long to see the realization of this idea? But this is exactly the best source of energy for the Earth, for the future.
Yeah.
And who knows the future? I mean, Rutherford early on said there's no indication that we'll ever be able to harness atomic energy. One of the early workers in the whole area, the first.
Let me tell you, it's not so efficient like my model. Let me tell you why. Because in atomic energy, each reaction gives you maybe mega electron volts energy. That's it. In my case, one interaction, two particles, tera-electron volts. It's only 6 orders of magnitude energy at one point immediately. That's why, this source of energy much more efficient because of these particles. They have a mass, tera-electrons, giga-electron volts, and all this stuff. That's why it's much better to use them, because at once you have so huge energy per each reaction. You know what I mean?
Yeah.
Right. So thank you very much, Nick. Anything else before we move on?
That's it.
Okay. Thank you again. Thank you once again.
Thank you so much, Rick, for everything. Nick, for everything.
Yes.
You done for me.
I know you've been very helpful.
Only because of your help, I could do the 7th presentations, and the last one will be in 2 weeks.
Well, thank you.
Thank you.
So I'm just moving on a little, and in the absence of any specific, requests, I just you're next, Jim, and have you anything you'd like to add about today's presentation, which is more specific?
Hello, Vladimir. Well, I have maybe 2 items. One is very trivial. We'll start with the trivial one. As far as I can see in WUM, your name for your overall theoretical work, the world word means universe. And so if that's true, it's sort of like we're saying universe model. So you might some people may find that confusing, because whenever we hear you're using the word world to refer to the universe.
You're just breaking up a little, Jim, although I think we have the germs of your position.
That's just a trivial English lost. Can you still hear me?
My understanding.
Yeah, we heard most of it, although you broke up a little.
I'm ready to answer it.
If I may butt in just for a second, I may be quite mistaken, but I was wondering if this is sort of a Russian language thing, where maybe the word world is also used for universe, because I noticed this as well, Jim.
No, it is not Russian world. No, it's an English world.
You see, English is normally the globe, just the earth. Now, we very, very occasionally talk of it in a universal stage, but maybe not very often.
Yeah, it could be confusing to English speakers. That's all I'm saying. It's a trivial point.
Much more confusing, not the name of the world or universe, because my model is a new paradigm for cosmology. That's why even the first definitions must be changed. There is no universe in a common sense what we have right now. There is the world we live in. There is universe infinity now. In my model, it's a 3D world as a hypersphere. It's not infinity. It's finite world. You see, universe always, even in your head, it's something infinite. In my world, it's finite. You can calculate the volume, you can calculate the density, and so on and so on. That's why it's totally different entity. Universe is what we have right now. World,
perhaps it's therefore
hypersphere.
Essentially total universe model. That wouldn't be too inaccurate, would it?
No, universe. I saved this name for universe like a god. I didn't know how to name it, because universe in my model, there is no any characteristic except of creation. And usually God is the creator. How to name this creation body? I don't know what is this. It is 4D ball. And I named it universe only because universe for me, there is something from God. I mean, from this world. That's why it's a totally different story. Universe we have without any properties, any characteristics. It's only creator. And world, it's a hypersphere on the 4D ball nucleus of the world. There is no nucleus of the universe.
We have a comment there, which I'm not au fait with totally, but
let me move
backing you up.
Let me move on to something that may be more interesting. Yeah. Your photograph showing the wall blown off of a small wooden building, in which there apparently was one of these ball lightning objects of very high energy.
Yes.
Somebody might say that looks like I realize that's one photograph from one reference of the hundreds that you reviewed, but what about could you explain in terms of your physics whether or not that photograph is actually possibly a hoax? Because if there is such high energy as you claim in these explosive ball lightning objects, how could it be that the wall is blown off in its entirety with no other particular damage to the wall laying on the ground in the photograph, and there's no singeing or evidence of heat damage to any of the cloth items laying around there inside the room where the explosion took place or on the surface of the wall? So in your physics, how is that explained, or might that photograph be some sort of a hoax?
You know what, first of all, I do believe Russian scientists, they investigate this phenomena for more than 100 years. Over 1,000 papers published. Every summertime, I know this for sure, they are going to the same place to find out what the hell is going on, what kind of explosion it was, and so on and so on. As for the heat, even in Tunguska event, if you will see the picture, the real picture, you will not see burning even forest. You can see these trees going outside as an explosion, and there is no burning of them. There is no, even you have your Tunguska event with much higher energy, and that's at the same time, you don't have a heat. You have explosion. You have your air wave very strong, very strong. That's why to destroy this wall, you need only pressure inside. You have this energy exploded, and you have your air wave, throwing away this wall. That's it, simple like this. That's why.
Could it be that the heat is so brief in duration that there's no normal combustion of objects? In other words, what is the physics explanation for this lack of burning?
You know, I told you, there is much more energy in Tunguska event. Please, at the Google, take a look at the picture of this area, and you will not see superheat. You will see all the breakage of them with different angle, trees for hundreds of kilometers, and no heat at all. Can you believe it? That's why inside of the house, you have the same phenomenon, but much less diameter and much less energy than Tunguska event. It is explosion. It is not heat. It is energy in air waves. I don't know how to name it. In pressure waves, in air waves. I don't know how to name it. And what is important, I am not expert in explosions, but I believe to these pictures published in the real paper, reported at some international conference. I gave you the reference. You can see the reference. That's why.
Thank you for your explanation. Thank you.
Yeah, so perhaps in summary, the very fact that you have this massive force blowing down the whole system, but not destroying the elements of it, that is actually something that supports your theory, according to the way you're looking at things.
Yes, sir, you're absolutely right. No burning of the forest, no fires. There was no fire even of this, thermonuclear bomb. If you will put it, it will be fire, will build everything. But because of explosion, you have even your earthquake with 5.0 by Richter, scale, and you don't have burning. You don't have fire, even at a much higher energy. It's a totally different phenomenon.
Well, that might be some really interesting physics to explore further, because that seems to be a little bit outside what one might expect. I suppose if there was great heat, also in addition to the trees not burning, as you said, or implied, you might find rock that had melted and such as is found, like, for example, glass sand turned to glass in where there were nuclear explosions and so forth?
More than 100 years, they investigated this area. They've done so much work. No one piece of anything, glass, stone, was found in this area. No, nothing. This is the main point of this Tunguska event. You have an explosion and no residuals, nothing. That's it. That's why when you have your meteor or something coming inside of the Earth's atmosphere, you can see some stones, some particles, some small pieces of something. In this situation with Tunguska event, you have nothing. You have nothing. That's why, how to explain this huge energy, huge damage, mechanical damage, and no heat, no any residual particle, because inside of my ball, big ball, because as I told you, this event, it's a big ball with a diameter maybe 80 meters, and inside, if you have only 0.4 cubic meter of this material for explosion, and then you have your explosion without anything else. I mean, without heat, without anything else.
Well, that sort of phenomena does seem to imply some new physics there that could be explored. Thank you.
Okay, well,
okay.
Thank you.
Hopefully somebody will be excited about my model and he will do these calculations based on my model. That's it, simple like this. My main intention right now to initiate some interest to a new approach in physics. And I cannot answer all this detailed physics for any particular area. I can only tell you, guys, try to use my approach, try to use my model. All the time I'm talking, it's a model only. It is not theory, because all the theory based on my model should be developed by entire physical community. This is my point. I'm trying to initiate this, interest to this model and to do this job.
And that's appreciated. So thank you very much, Jim, for raising those. I mean, it's been also pointed out that although Siberia has been very sparsely populated, the event occurred in an area where there was nobody around, and it could easily actually have hit a populated area. Anyway, that's another point.
There was some Russian settlers. It's not only event yet at that time. It was, there were some Russians, not so many, and of course we didn't have fort or something.
Nobody was hurt or anything like that.
Yes,
and it seems to be a bit of a phenomenon. Like whenever you've had these meteorites, if you like, hitting the Earth, they've normally been in unpopulated areas. It's just been pointed out. Just curiosity.
Yes, we have so many fireballs coming every day to our
that's right.
And we know nothing about it. There is some special station, they fixed it, and nobody asked the question where they came from and what is the origin of them. It's exactly my point. Please take my model for explanation and try to explain your results through my model. That's it.
Okay, well, I think that has certainly given us some aim to look at that. Harry Ricker has joined us, and we haven't heard from him. Good day, Harry, for a little while. I don't think we've really heard from you in regard to Vladimir's ideas, certainly the ideas which he's expressed today with regard to high atmosphere physics. And I wonder what your reaction is, or have you any questions to him? Or
okay, I have my question is you talked about three things: lightning, regular lightning, ball lightning, just event. And my understanding is that the energies involved cannot be explained by normal physics. See, there you go. So the connection's not working.
We can hear you. You might have broken up once or twice, Harry, but we can hear what you've said. You've gone off now, though.
Oh, my goodness.
Yeah.
Can you hear me, Harry? Oh no.
Yeah, this
Because
has
I
happened
so
before.
much appreciate his, he initiated my transfer from dark matter to universe created matter. It's because of him I changed my mind, and he was absolutely right.
Yeah, I
That's
know.
why my appreciation for his help. The second,
And when I saw him coming early, I thought his connection, he had problems. The problems were resolved, but obviously not.
oh my God, I
I'm
wanted
sorry
to
about
see
that.
him and to answer his question.
Can't hear anything.
Well, you're
Harry?
back there, Harry, with no photo, though.
Where is Harry? Oh my goodness.
You say something? I thought we heard him there.
Oh, it's a great pity for me because I wanted to see him in person, not by communications.
And I'd like to have his input to these sessions. Maybe if we don't get it in the next few minutes, hopefully for the last session of yours, Vladimir, we might have Harry coming in and maybe giving us his own take on the.
But let me give you the very small comment right now. As I told you during my presentation, that Piotr Kapitsa, he told that it should be new physics to explain ball lightning, because he proposed his own model, and he saw it didn't work. And all of them, it did work. And he was a very creative guy, Nobel Prize laureate in physics, and so on and so on. I knew him personally. But what is important, the second one, Van de Wander, he told we must have a new physics. That's why people, they told already that with existing physics, and they were expert in their areas, there is no way to explain this phenomenon. That's why, as for me, I propose new approach, new ideas, how to solve these issues based on this guess of Kapitsa and Van de Wander.
Very well. Well, just prior to asking you to summarize, I just had one question here from Cornelis, which maybe with your permission I'll put to you before I ask you to summarize, Vladimir. It's this. He's asking, what holds a UC particle together, and why do they exist in only a few specific sizes? How are they formed? Say a word about that.
UC particles, universe created particles, they came from universe. How they were created, I have no clue. That's why the first question I answered. The second very important point, our standard particles, what we have right now, they have only electrical interaction, in far away. And that's it. These UC particles, they have weak interaction, super weak interaction, and extremely weak interaction. There is interaction between particles because gravitation, it's only mass. You must have a big mass, more than Planck mass, and then you have your gravitation. Electrical interactions, we know what does it mean. But as for these particles, they have much more abilities to connect each other, to interact with each other. Everything depends on the interaction strengths. If you have very strength, you have your weak interaction, you have small area of this interaction. If you're going with the next super weak interaction, it reaches much higher, 10 orders of magnitude, larger area. And the same story with our world. The whole world, the integrity of the whole world depends on the parameter Q is power 1, means we have integrity of it because of gravitational gravitational interaction. No, because of interaction of all the particles inside of this big, huge ball of our world.
All right. Just reading a comment from Jim. UC particles might be consistent with binary mechanics and consist of specific spatial temporal patterns of one state loci called quanta. If so, some of Vlad's ideas might be tested using the BML simulator software. Yeah, I think you're aware of that. The work that Jim has been doing on binary mechanics, and the fact some of these elements could be tested on his simulator. So that's something maybe you could deal privately between the two of you. So is there anything else you'd like to say in a minute or two, just before I close the meeting officially, Vladimir, or have you said it all?
I practically said it all. First of all, I would like to say, everybody, thank you so much for coming, for good questions. I hope you will have more questions and you will contact me directly. Then in a written form, I can answer all your questions. I'm very glad to pass already 7 presentations. I will be very happy if you will join me in 2 weeks with the number 8, last my presentation, and I will be more than happy to answer all your questions at once. Thank you so much, and see you in 2 weeks. You're very welcome. Bye now.
And once again, I'd like to thank you very, very much, Vladimir, on behalf of the CNPS and all our participants, and certainly myself, for all the sterling work that you have engaged in, and for the patience with which you have described the work of many, many decades, really, to us. You've made it as clear as possible, because we haven't been working on the subject or in your specific area. So you've made it very clear. For my part, I think I've been able to follow most of what you've said. And I'd like to thank all the participants for their questions and discussion. And indeed, we had good input today from the people in the green room. I'm sorry Harry was cut off. He was cut off, actually, the most important part. But all the other participants, we had uninterrupted contributions. So maybe Harry can make up for that at the next presentation. I do look forward to the last presentation, and thank you very much once again, Vladimir, for having validated what I sort of guessed at, that there would be an opportunity, maybe more of an opportunity, at the end of the 8th session, the next session, to engage in anything that was unclear, any sort of global thing, these sort of questions that Quest was putting in. Okay, you've done a lot of sterling work, but what is your ultimate conclusion? That we have infinite energy, or that things are changing, or that we have to revise our fundamental ideas of physics. I'm sure that the last point won't come as a surprise. So we can deal with all these elements. And in fact, I find very interesting that he'll be talking about the intersection with classical physics, that he's basically dealing with classical physics. I think Vladimir has mentioned that a number of times, that he wasn't primarily a quantum physicist. He was dealing with what might be called classical physics. So I think that will be dealt with in more detail in 2 weeks' time. The session has gone very quickly for me, even though we haven't had it every week. We've had it every 2 weeks. But so far, I suppose it's 14 weeks. It might even be actually 16 weeks, because we had in the early stage, we had an interruption. We had another talk on that. So the time is caught up on us again. If there's anything that's unclear, or anything you're unhappy with, or maybe suggestions for teasing out things further, please drop an email to us. Please, all of you, and anybody who might be listening to this recording who couldn't attend today, please do endeavor to attend the next one in 2 weeks' time, because it will be the final summary of all the presentations, and closing up and dealing with any fundamental questions. I'd like to thank you all again for participating. Thank you for your patience in bearing with my weak attempts to summarize and to bring things together. And thank you, as always, Vladimir, for making my job so easy, because you've been very clear in your exposition. You've been very patient in addressing any questions or any points that have been put. And we look forward to the completion of this marathon series that you've been so kind to offer to present to the CNPS. So I'm going to stop the stream, which means we stop the recording. And if any specific questions that any of you have, to make privately to me, I'll be here for a minute or two afterwards. But I'm going to end the recording now. And thank you all very much indeed on behalf of the CNPS. Thank you.